Let's go through the factorial designs worksheets. Um, this experiment was had two independent variables, type of music and temperature. Those were IV1 and IV2. The two levels of type of music were classical and silence. The two levels of temperature were 60 and 80 over here. The dependent variable was recall because each of these numbers that I'm recording in here, each of these 8 numbers was a recall score. What I did was I calculated the average of each of these boxes. So what I did was I got the average of 8 and 10, which is 9. The average of 5 and 7 is 6. The average here is 7, and the average here is 4. I didn't have to add them and divide by 2 because whenever you have two numbers, the mean is the number that's halfway between. So we had a shortcut we could use to get the mean right here. And if we did do the math, we would just do 10 plus 8 is 18. 18 divided by 2 is 9. So these 4 numbers in here are called the cell means because each box is a cell. These means down here, the column means, and over here the row means, are called marginal means. What this mean right here is the mean of all 4 numbers in column 1, the mean of 8, 10, 6, and 8. If you add those 4 numbers and divide by 4, you get 8. Over here, if you add these 4 numbers, 5, 7, 3, 5, and divide by 4, you get 5. This mean over here is the mean of all 4 numbers in row 1. It's the mean of 8, 10, 5, and 7. This number right here is the mean of the 4 numbers in row 2. It's the mean of 6, 8, 3, 5. And this says, what is there a main effective type of music? To be able to know if there's a main effective music, you have to compare the mean of all 4 people in the classical column, which is 8, and the mean of all 4 people in the silence column, which is 5. If the mean of the classical condition and the mean of the silence condition are not the same, then there is a main effective type of music. And we can see that 8 and 5 are different. They're not the same number. So yes, there was a main effective type of music. Classical music did do better than silence. Is there a main effective temperature? To find out, we have to compare the mean of all 4 people who were in a 60-degree room and the mean of all 4 people in the 80-degree room and see if they're the same number. They're not the same number. So yes, there is a main effective temperature because the mean at 60 degrees was higher than the mean at 80 degrees. The 4 people who were in a 60-degree room did better than the 4 people who were in the 80-degree room. So yes, there was a main effective temperature. Now, if these 2 numbers down here had come out to the same number, if they had been 5 and 5, there would have been no main effect of music. And if these 2 numbers had been the same, for example, if they had been 7.5 and 7.5, there would have been no main effective temperature. Is there an interaction? To find out if there's an interaction, we have to plot the cell means in a graph. If you wanted to just use the table, what you would do is you would look at how far apart these 2 numbers are in row 1, and you would look at how far apart these 2 numbers are in row 2. If the difference between the 2 numbers in row 1 is not the same as the difference between the 2 numbers in row 2, then that would be an interaction. Now let's take a look at these numbers. 9 and 6 are 3 apart. 7 and 4 are also 3 apart. So the difference in row 1 is 3, and the difference in row 2 is 3. Since they're the same difference, there's no interaction. And if we plot them in a graph right here, we can see that at 60 degrees right here, the averages for silence and classical are 6 and 9. That's just right here. 6 up to 9. In the 80-degree room, right here, the numbers are 4 and 7. So 4 for silence, 7 for classical. This line goes up by 3. This line also goes up by 3. So the lines end up being parallel, and there's no interaction. So there's no interaction right here, and the result is showing that the effective type of music does not depend on temperature, because if it's a 60-degree room, classical is 3 higher than silence. If it's an 80-degree room, classical is still 3 higher than silence. So the effective type of music is a 3-point difference at both temperatures. So no, the effective type of music does not depend on temperature in this data set right here. Now let's take a look at the next one. Here we have a different result. I just did these calculations over again with these new numbers. The two column means are different for classical and silence, so there is a main effective type of music. The two row means for 60 and 80 degrees are different right here, so there is a main effective temperature. And in the first row, we have a difference of 3, because the difference between 6 and 9 is 3. And in row 2, the difference is only 1, because the difference between 4 and 5 is only 1. So since the difference is not the same in the two rows, there is an interaction. So if we plot them in a graph, we can see that it's not parallel. And since it's not parallel, there is an interaction. It's a yes. So at 60 degrees, in the 60-degree room, classical is 3 higher than silence, because it goes up from 6 to 9. But in the 80-degree room, classical is only 1 higher than silence. It only goes up by 1. So the line is not as steep. It's steeper here and not as steep here, which makes them not parallel, and there is an interaction. So remember, parallel lines means no interaction. Non-parallel lines means there is an interaction. And what is this interaction showing? Well, it's showing that the effect of the classical music is steeper when it's 60 degrees and not as steep when it's 80 degrees. So it looks like classical music improves recall more when it's 60 degrees and not as much when it's 80 degrees. Does this result seem to be showing that the effective type of music depends on temperature? Yes, because when it's 60 degrees, the difference from silence to classical is 3. But when it's 80 degrees, the difference from silence to classical is only 1. So the effective type of music does depend on temperature in this data set. It's a bigger effect at 60 degrees and a smaller effect at 80 degrees. So it does depend on temperature. Here, I did everything over again. These two means are equal, so there's no main effective type of music. These two means are equal, there's no main effective temperature. But look what we have right here. When we go from 6 up to 9, so what you might be thinking right now is, if you go from 6 up to 9, that's a difference of 3. And when you go from 6 up to 9, that's also a difference of 3. But so we have a 3-point difference in both rows. But the thing is that the difference we have here is the opposite of the difference we have here. Here, when you go from silence to classical, you go up by 3. You go from 6 up to 9. But in row 2, you go from 9 down to 6. You go down by 3 when you go to classical music. So when you graph the lines right here, you see an X like this, because in the 80-degree row, which is this line right here is the 80-degree line, you have a recall score, an average recall score of 6 for classical, and an average recall of 9 for silence, like this. But when it's 60 degrees, which is this line right here, you have an average recall of 9 for classical and an average recall of 6 for silence. So it's an opposite. They're the opposite of each other. And when that happens, there is an interaction. The lines are not parallel, so there is an interaction. So what this interaction seems to be showing is that classical music improves recall when it's a 60-degree room, because in a 60-degree room, recall is at 6 at silence and goes up to 9 at classical. It shoots up like this. But when it's 80 degrees, in the silence room, when there's silence, the recall is at 9. But when you go to classical, it drops down to 6. So classical improves recall at 60 degrees, but lowers recall at 80 degrees. The music has an opposite effect at the two temperatures. So this result seems to be showing that the effective type of music depends on temperature. Yes. Because there is an interaction. Here we have a 2 by 3 design, 2 temperatures and 3 types of music. And I just filled all of those in right here. To find out if there's a main effective type of music, you have to compare the 3 averages for the 3 columns. If they all come out to the same number, like 7.5, 7.5, and 7.5, then that would be no main effective type of music. But if at least one number is different than the others, there is a main effective type of music. So these 3 numbers are all different from each other, which means that there is a main effect type of music. And if it had been 7.5, 5.5, 5.5, that still would have been a main effective temperature, because we still would have had a difference in here somewhere. These 2 numbers, the 2 temperature averages, the 2 recall averages right here for 60 and 80 degrees are different, so there is a main effective temperature. Is there an interaction? Well, when you plot these cell means, so in the first row it's 5, 7, 9. In the other row it's 2, 4, 6. They end up being parallel, which means there's no interaction. What about this right here? Well, let's look at the main effects first. We have 6, 4.5, and 4.5. These means are not all the same, because 6 is different than 4.5, so there is a main effective type of music. These 2 numbers are different, so there is a main effective temperature. And when we graph the cell means, we have 3, 3, 3 for the 80-degree row, and 6, 6, 9 for the 60-degree row. They are not parallel, so there is an interaction. And what does this interaction look like? Well, it looks like when it's 60 degrees, people do better at the recall task with classical music up here, and they do worse with both jazz and rock. But when it's 80 degrees, people do equally poorly with all three types of music. So classical music leads to better recall than rock or jazz when it's 60 degrees, because 9 is higher than 6 and 6. But that's not true when it's 80 degrees, because when it's 80 degrees, the recall average is 3, regardless of what type of music you're listening to. So it's answer B. And the effect of type music does depend on temperature, because classical music leads to better performance than jazz or rock, but only when it's 60 degrees. If it's 80 degrees, that's not true anymore. So the effect of the music does depend on temperature in this data set. Let's look at another one. But first, I said that there is an interaction because the lines are not parallel. Here the line stays flat all the way across, and here it has a jump in it. So they're not, the two lines are not parallel. So there is an interaction. Let's look at this one right here. Well, is there a main effective type of music? We have 7.5, 4.5, and 4.5. So 7.5 is different than 4.5. So since these three numbers are not all equal to each other, there is a main effective type of music. Since 4 and 7 are different, there's a main effective temperature. But when we graph the lines, in the top row we have 6, 6, and 9 right here. And in the bottom row we have 3, 3, and 6, like this. And these two lines end up being parallel because the shape of this line is exactly the same as the shape of this line. So the two lines are exactly the same, which means that there's no interaction. And the effect of music does not depend on temperature in this case. Let's now look at the three-way interaction.